let's see what are the different types of, so far we have seen what pattern recognition system is, what are patterns are, and what are the typical real-time applications of pattern recognition system, all these things, right. So now let's see what are the different types of machine learnings that are available. So basically you can categorize any of the machine learning or the pattern recognition algorithm into 4 types. So the supervised learning, semi-supervised, unsupervised, and the reinforcement learning. So these are the types of machine learning algorithms. We will see in detail. So what supervised learning is, what unsupervised is, and where it can be used. We will see that shortly. And so let's start with the first very basic learning, that is supervised learning. So in this case, the supervised learning works similar to how we humans learn. So how we humans learn? So we basically learn based on our experiences, right? So here if you observe, so consider the baby. So to the baby, if you show the apple, then the next time when you show him, so he tries to identify the patterns in the apple, right? So then later on, so when you show the apple again, he will start uttering apple. So that's how basically humans learn. And similarly, when you show banana for a few times, later on he identifies, so it as a banana. Say for example, on showing the apple, so if the boy utters as banana, then what do? So no baby, this is not apple, this is banana. That is how we correct him, right? So the same kind of feedback mechanism is available in case of the supervised learning. So if that kind of feedback mechanism is available, then we call such a learning as supervised learning. So when the model is making any mistake, then so there is a teacher to correct, and so the model is trying to incorporate the changes accordingly. So that is how this learning is called as supervised learning, as there is a presence of, so this learning is happening in the presence of the teacher. So or you can call them as supervisor itself. So that's why this learning is called as supervised learning. So let's see what this supervised learning is in detail. So here what happens is every sample in the training data is associated with some label, or you can even say that it's a class. So every data sample in the training data is associated with the label or class, and the models are trained on the labeled data alone. So they cannot be trained on the unlabeled data. So every sample, so consider this example here that I am using. So here these are the samples that I am going to give as input to your model. So in that case, so here along with this object, I will say that, so this is the hexagon. So that is the label that I am associating with this kind of object. Okay. So not only the data, I am passing this label also along with data to the model. So this is an hexagon. I will include that a kind of label also. So and say for example, this is hexagon. So I include that input also. And similarly, this is also hexagon, this is also hexagon, this is triangle, and this is a square, this is a triangle, this is square, this is square. And then after labeling the data, then I pass it to the machine learning model. So once the once you pass the data, labeled data. So now you observe, so the the important point to be understood is, so every label in your training data is labeled. So without label you cannot pass it to the model. So once it is labeled, you can pass it to the model. So when you pass it to the model, so now after training the model will be ready. So after the model is generated, you can use it for predictions, right. So while predicting, what you can do is, so when I am giving the test data, I will not pass any sample here. I will be passing only the data itself. So try to understand, here this process is called as training. So when you pass for the training, then you have to give the labeled data. But when you are giving for the test data, it's not labeled. So there are no labels here. For the data, there are no labels. Simply pass the data itself. So if you pass this example or this object to your model, what it does is, so it itself will produce the label for the object. And similarly, if I pass this kind of image to the model, then it's saying that it is triangle. So that kind of learning is called as supervised learning. So basically in this learning, what you are doing is, so you are collecting the data and you are associating a label with each and every object in your training data, and you are training your model. Once the trained model is available, then you are providing some objects to your model, and then it is producing the outputs for those objects, that is the labels for those objects. So that is how the supervised learning works. And there are different types of learnings in this supervised learning. So in supervised learning you can consider the regression. So supervised learning can be categorized into two different tasks. So one is the regression task and the other one is the classification task. So these are the two tasks that comes under the supervised learning. Let's try to understand so what classification is and what regression is. So in both the cases, so you should remember that, so the data is labeled because, so both are the examples for the supervised learning itself. So both regression and classification algorithms, so the data is labeled. Before you feed the data to your model, so it should be labeled. Okay. So then once the data is labeled, you are passing it to your model, and the model is producing something, right. So that is, so it's predicting. In both the cases also the model is predicting. So that is here prediction. It is happening, prediction is happening in both the cases. But how they are different is, in case of the regression model, so the value produced by the model is a real value, or you can call it as a continuous value. If the model is predicting a continuous or the real value, then such type of prediction is called as regression. Whereas in case of the classification, so your model is predicting a discrete value. So maybe you can consider it as an integer value, or you can consider it as a binary value. So when your model is producing this kind of data, so then you can call it as a classification algorithm. So I hope it is very clear. It's very, very important to understand these two things, because many people don't get this. When the problem is given, so you should be able to clearly tell whether it is a classification problem or the regression problem. So try to follow this. So in supervised learning we have two different types of tasks, or supervised learning can be used for two different tasks. So one is the classification and the other one is the regression. So in case of the both in classification and regression, so your data, input data should be labeled, and both are used for prediction itself. But how they are different is, in case of the regression, the value you are predicting is a real or the continuous value. So continuous means, so the output can be a continuous value. But whereas in case of the classification, the prediction value is an integer or the binary, that is a discrete value. So now consider this example. So let's start with the regression task itself. Okay. So you can even consider classification is a specific type of regression. So basically regression is predicting. So in regression, so your output should be a continuous values. So in that case, if it is a integer, that is a discrete type, then you can call it as a classification. So classification is a specific type of regression, or regression can be considered as more generalized version of the classification. So now let's have an example of the regression task. So I am considering the predicting house prices for this example. In the house price prediction example, so for the first 3 records, so I have given, so the input data, this is the input data, right. So the features I am passing is the area of the house, the number of bedrooms and the number of bathrooms. So these are the 3 features I will be giving as input to the model, and so the price along with the features, that is these are the input data. So for this house, this is the size of the house, 5 bedrooms, 3 bathrooms. And another house which is of size 2100 square feet, it's having 4 bedrooms and 2 bathrooms, and its price is, so for the first house the price is quoted as $5,30,000, and the second price, its second house price is quoted as $4,60,000, and similarly for the third house, these are the details and this is the price quoted. So now similarly, so I have some certain examples. Here I have taken only 3 examples. So I will be having certain house price examples along with these the size of the house, bedrooms and the bathrooms. Along with that, I quote the price also. So that will be passed as input to your model. Okay. So now the model will try to analyze the data and generate a model, and that model will be applied later when you give some input. Here later when the model is ready, then I will pass this example, the house details, to the house prediction model. Then so I am saying that the square feet, 3950 square feet is the house size, then with 6 bedrooms and 4 bathrooms. So please predict what is the price. So now the system will produce the predicted value for you. So basically, so you are providing certain label data to your model, then the model will be trained and the model will be generating the output. When after generating the model, if you pass some new test sample, so it is generating some output, right. So this is called as regression. Why we are calling it here? It is predicting the house price, right. So the output is when the test sample is given, so the model is predicting the house price. Why we are calling it as regression? When we can call it as regression? So if the value is continuous, the prediction value is continuous or the real value. So now if you observe, the house prices can be any value from, so maybe something like 1 lakh to 1 crore also, right, or even 10 crore, 50 crore also. So it can be any value in this range, right. So maybe something like I can say that 1 lakh 10 rupees also I can say, is it not? I can say this, or even 1 lakh 10 rupee 50 paise. So you can't say that this number cannot be the house price value within this range, right. So the value ranges from some x to some y, and it can take any of the values in between. So it's a continuous value, right. So when your model is predicting a continuous value, in that case such task is called as a regression task. And now let's consider the classification task. So classification is also a supervised learning task, and your model is predicting some output, and the type of prediction here is an integer or the discrete integer binary values, right. So now consider the example. So here I am taking the example as identification or classification of given mail is spam or not. So in this case what I do is, so assume this is your machine. So to this machine, so I am providing the data. So this is the mail, and along with that mail I am saying that it is non-spam mail. So that data also I produce. I feed the data along with the label, right. That is what the supervised learning is. So that is why with the mail I say that it is a non-spam mail, and with this mail I say that it is a spam mail, and likewise I produce certain number of examples, number of such examples, say for example 1000 or 2000 or even 1 lakh examples to get a better model. So the more data you produce to your machine, so the better the model that is produced by your machine. So to summarize, what am I doing here is, so I consider some example mails, so which I know they are the spam and non-spam mails, and I give the label also. So I pass all the mails along with the labels to the machine, and now the machine will produce a model. So here the model is trained and the model is the model is ready. Now you can use it for testing. So when I give a new mail later on, then it produces that. So if it is a spam mail, then it will say that it's a spam. If it is a non-spam, then it should say that it's a non-spam. So here, if you consider the output, the type of prediction, here also it's predicting, here also it's predicting. Here it's predicting a continuous value, but here it is predicting a binary value. In this case, it is binary. Say for example, if it is spam, then I am saying that the output is yes. If it is non-spam, then it is no, yes or no, true, false, right? So that means, so here in this case, the output produced by the model is a binary output. Or you can even extend this. So maybe, so given set of mails, so my prediction should be, so I am expecting that the model should predict as, so it is a spam mail or the primary mail, or it is a promotion, or it is the social event, right? So that's how Gmail categorizes the mail. How it is happening? So basically, so they are running a model to categorize, and automatically the model is predicting when a mail comes to our inbox. So it automatically checks and categorizes into, so either as a primary mail or a spam mail or what you call promotion or a social event or an update, right. So, in that case, how many predictions are possible? More than 2. In that case, it is not 2. So, it is a spam, it is a primary, it is update, it is a promotion. So, altogether there are 4 classes. So, can I say that it is an integer output? So, 1, 2, 3, 4, 4 classes I have, right. So, that is how if your prediction value is an integer or binary. So, that means it is a discrete value. In that case, so that task is called as classification task. So, if your model is predicting a continuous value, then I am calling that as a regression task, right. So, I hope it is clear. It is very, very important to understand the difference between regression and classification. So, you should not get confused. So, when the model is predicting a continuous value, it is regression. The takeaway is here is that. So, when you are predicting a binary value, then it is a classification. Now, so let's so far we have discussed what supervised learning is and what are the types of problems that can be solved using supervised learning. So, in supervised learning, you are producing the data, you are feeding the data along with your labels to your model while training. And while testing, you are not producing any label, only data is produced and the model itself will produce the outputs. So, that kind of learning is called as supervised. So, why it is called as supervised? So, the model is trained under the supervision. So, here if you consider the labels itself will act as supervisors, right, or teachers. So, the feedback mechanism is available in case of supervised learning. So, such kind of learning is supervised learning. And now it is not possible to get the label data in all the occasions. But even then I need to get some, I need to analyze the data. So, then is there any kind of learning that supports on the unlabeled data is the unsupervised learning. So, there is another type of learning called as unsupervised learning which can be applied on the unlabeled data. So, I have the data but I do not have any labels for that data, but even then the model can analyze some patterns and can do some tasks. So, such kind of task comes under the unsupervised learning. So, here also of course, so however the humans learn or analyze, right. So, the same way the model will try to analyze and so like you are kind of your model is kind of analyzing the data and your training data is not labeled and your testing data of course is not labeled and models are trained using these unlabeled data. So, nothing is labeled here, both for the training and the testing you are passing only the unlabeled data and the models are trained without any supervision because there are no labels, you cannot have any feedback mechanism, that is there is no supervision at all. So, such kind of learning is called as unsupervised learning. So, here what am I doing is I am passing set of images, assume I am passing set of images. So, here it is a cat, another cat, right. So, another dog and another dog. So, 4 set of images I am passing as input and I am not giving any labels if you observe. So, here in this input just for our understanding, because we know they are the cats and dogs, I am discussing that, but the model to the model I am not saying, I am not revealing anything about the label. So, I just give these 4 images to the model. Now, the algorithm will be designed, the algorithm will be trained on this data. So, just the raw data and the pre-processed data you are passing without any labels and then the model will be generated. So, then what the model does is whatever the data you are passing, so it is grouping into 2 groups, 2 partitions, right. So, that itself is categorizing the data into its analyzing. So, depending on the patterns that are available in the input data, the model itself is grouping the data. So, here this is one group and these 2 are belonging to the another group. So, that is what the kind of output that is produced by the model. Here also the model will not say that these are dogs and these are cats, that will not be generated. Just for our understanding I just labeled it, that is all. So, you are producing the unlabeled data to the model and what the model does is basically it is grouping, it is kind of analyzing the patterns in the data and in this case, in this example, it is kind of categorizing the data into groups. Let us see what are the tasks that comes under this unsupervised learning. So, basically there are 2 different tasks that comes under this unsupervised learning. So, one is clustering and maybe you can consider anomaly detection as unsupervised learning and if you, as long as you do not produce any labels, Or you can even consider the dimension reduction also. So dimension reduction is also, or density estimation. So dimension reduction and the density estimation, these are all the examples that tasks that comes under this unsupervised learning. Density estimation. Now let's see. So we'll be discussing these two examples in detail now. So let's see what clustering is. So here basically what unsupervised learning is, you are not providing any labels. So please keep it in mind. So there are no labels. Let it be anomaly detection, let it be clustering. So there are no labels, only the data is passed to the model. And depending on the application, it is doing something, analyzing and producing the output. Now consider, so what clustering is. So clustering is basically, so whatever we have seen in the previous example, no, that's an example for clustering itself. So given the samples, so the model itself is identifying and grouping the objects into similar. So the similar objects are identified, it's grouping them into one group. And similarly, these are the similar objects and it's grouped into another category, right? So that kind of grouping of things into one unit is called as clustering. So clustering is basically grouping of similar things into one category is called as clustering. So now I'm quoting an example, so which is called as image segmentation, so which is very interesting. So if you consider this example, the image segmentation, so here if you observe, so can you see the outlines here? So the white outlines, you can see the segments or the partitions, right? So similar pixels are identified or categorized into one group. So here if you observe, so water is grouped into one object, right? And see your green grass regions are identified as other regions. So then, so this is the mud portion or the land portion, it's identified as another region, or maybe the sky portions are identified as another regions. So this is an example for clustering. So maybe given a satellite image, so you can easily identify which is the forest area, which is the living area. So that kind of applications. That are the applications of the clustering task. So what is clustering? Clustering is basically grouping of similar data items into one unit. So that's that task is called as clustering. An example is the image segmentation or the dog cat categorization. So remember, there are no labels that are given to your input. So here, am I providing any label? No. Nothing. Even output also, it's not providing any labels. It is simply saying that, so these are all the pixels that are belonging to the same group. So these are all the things that are belonging to the same group, right? So that's what clustering is. Now consider the anomaly detection. So the second type of task that comes under the unsupervised learning is the anomaly detection. So now, so I just provided some set of bank transactions. You can assume them as a set of bank transactions. So I am just providing the data. Again, there are no labels. So the data are date, customer, account, so authorization, so the type of authorization using, then what is the product that he is buying, and what is the zip, that is the location. So then what is the amount? So given these transactions, I need to identify one of the anomaly, that is abnormal transaction. So if you observe quickly, so can you try to figure out which is the abnormal transaction? So if you observe, this is the transaction, so which looks like an abnormal transaction. If I observe this amount, so it's abnormal, right? So other transactions, it's less than 500, but it's 2,500. So that's how, so you can use it for unsupervised learning for the abnormality detection. So even the density estimation and dimension reduction also comes under the unsupervised learning. So just try to understand that. So, so far we have seen what supervised learning is, what unsupervised learning is. So, so let's try to have a detailed discussion or the differentiation of the supervised and unsupervised learning are. So in case of the supervised learning, the type of data you are providing to the model is labeled, and unsupervised learning, it is unlabeled data. So nowhere you are providing any labels. There is no feedback mechanism, right? So in case of the unsupervised learning, there is no feedback mechanism. But here you are providing some kind of supervision. So like you are giving a feedback to the model. So that's how the training, the type of training you are using is, so with the help of the feedback supervisor, you are providing the feedback. And if you consider the number of classes, in case of the supervised learning, So let it be the regression or the classification. So the number of classes are known. So of course in case of the regression there are no number of classes, but in classification your number of classes are known. But in the unsupervised your number of classes are not known, it's unknown. So in case of the image segmentation, you don't know how many types of regions are available. So all the green regions are similar, so we are packing that into a single unit. So that's how we do. And the objective here, these models are trained with an objective of predicting a value. So here in supervised learning, you are going to predict a value. So if the predicted value is a continuous value, then you are calling that as a regression task. If it is a discrete value, then you are calling it as a classification task. But here you are trying to analyze the patterns in the data in case of the unsupervised learning. So you are not predicting any specific value. So based on analysis of the patterns in the data, you are grouping similar things into one pack. And the types of problems that can be solved are, so using under supervised learning, so classification and the regression are the tasks. And under unsupervised learning, so you have clustering, density estimation, dimensionality reduction, and of course abnormality detection also. And now, so far we have discussed supervised learning and unsupervised learning. So in case of the supervised learning, there are no labels. In case of the in case of the supervised learning, there are labels. But in case of the unsupervised learning, there are no labels. But there are certain applications where, so only few examples are having data, and for large amounts of data, there is no labels at all. So can we make use of both these labeled and unlabeled data, and to model the to create the model which is much better than using the labeled data alone or the unlabeled data alone. That is, you are using both the labeled data and unlabeled data to exploit the benefit of large amounts of unlabeled data. So means, so the possibility is a semi-supervised learning. So the learning that is available, which allows the use of both labeled and unlabeled data, is called as semi-supervised learning. So which uses small amounts of labeled data and large amounts of unlabeled data. And such learning algorithm is called as semi-supervised learning algorithm. So of course, it stands between both unsupervised and the supervised learning. And here, useful for the applications which are having limited labeled data for training. So there are certain applications like speech data. So all the speech signals cannot be labeled, right? It's very tedious. So in that case, so we don't have the transcript for all the speech signals. So we have only limited data. So in those kind of cases, so where the limited data is available for training, we'll be using this semi-supervised training. And let's see the difference between these three types of learnings. In case of the supervised learning, if you observe, no, so the input is, say for example, I am passing this input data to the model. All the examples are having labels. In case of the unlabeled data, unsupervised learning, so all the data are unlabeled. There are no labels. But in case of the semi-supervised learning, so the data is available, and to whatever the data I am passing as input, so few examples are labeled and there are large number of examples with unlabeled. So such kind of learning is called as semi-supervised learning. So now let's see, so how the semi-supervised learning can be done. So I'll just explain one type of algorithm for the semi-supervised learning. So we already discussed that we'll be having small amounts of labeled data and large amounts of unlabeled data. So on this small amounts of labeled data, so we select one of the model. So for the simplicity of the explanation, I have taken the neural networks model. So now I have the neural networks model, and I am training this neural network model on this limited set of labeled data. So now after getting the model trained, what I do is I apply it on the unlabeled data. So once I apply the model on the unlabeled data, I get some predictions, right? So and after getting the predictions, I'll check for the confidence of the labels that I get for the unlabeled data. And all the confidently labeled data, I add it to the labeled data. So now, so my labeled data will be increased, right? So the labeled data with the confidently unlabeled data. So now if you Observe, this is the initial label data, the size is very less. But now I added the confidently labeled unlabeled data. Now the size of the labeled data increases. And now I run the model again on this augmented labeled data. So now again I repeat this process again and again. So again on the unlabeled data I am applying. Again I extract the confidently labeled unlabeled data. So this process will be repeated for certain number of times, or as long as there is no unlabeled data that can be confidently labeled. So whatever the final model that I get is the final model, and definitely it will be better than the model that you are training on the labeled data alone. Right, that is how. So this kind of learning is called as self-training algorithm, a type of semi-supervised learning, and it is called as self-training.